starting here about the linked list collection. So unwordly, a linked list appears to be the same as an array list. So of course, they both of them they implement the same interface. So just a little back here, we can see the interface list and then the array list and linked list, both of classes implementing the same interface. So if they implement the same interface, we can interact with them in the same way. They follow the same contract or protocol, but internally the details are a little bit different. Okay. So it is implemented as a linked list, a set of individual elements, each storing a link or reference to the next and previous element. So this is how a linked list works. Okay. And I'm gonna show you a diagram on the next slide representing how it is this if you are not familiar with the concept of a linked list. Okay. To insert an element in the middle of the list, you'll only have to change the reference of its immediate neighbor. So we have this difference between array list and linked list. Array list is like a list implemented as an array. So you know from the arrays that if we want to add an element in a specific position that it is already occupied, we need to manage and shift all the other elements uh, forth. Okay, so if we have an array of size 5, of length 5, and we have all the positions occupied, I mean, actually, 4 of them, so 4 of 5 are occupied, and from 0 to the index 3, and we want to add a new element on a specific position, let's say the index 2, we need to move forward the elements on the index 2 and 3. Okay, so we have an array of 5 positions, and then we have 4 of them are taken, and we want to add a new element in this specific position, the index 2. So we need to move both of them, we need to shift them, and add the new element right here. So this is how it works on the with array lists. But using the linked list, all the elements they store a link or a reference to the next and the previous element. So when adding an element in a specific position, we only need to update 2 references. The element which is before and the element which is after. We need to update those references. So what are the consequences of that? Add an element, use the method add, which comes from the interface list. It is fast for an array list, but it is very fast for a linked list. To insert an element in a specific position that it is already taken, it is slow for an array list and it is very fast for the linked list. To get an element, very fast for array list, but it is slow for linked list. Okay, so do you remember that in array list they use indexes as the arrays? So it is really fast to access any specific position, like give me the element on the index 0, on the element on the index 10, on the index 100. So it is really fast because it is all of the elements they are indexed. Okay, but for a linked list, it is like uh, give me the next one, and for you, the next one, and for you, the one after that. And we need to go one by one. So it is slow to get an element. To set an element, the same reason. So very fast for array list, slow for linked list, and to remove, the same as to insert. So it is slow for array list since we need to move all the elements that they are after the removed element. So we will not get um, blank spots inside of our array list. But for a linked list, it is really fast because we don't need to set the the link or reference between those elements. Okay, so the people say out there that nobody uses linked list. So the array list class began to be able to insert elements into the middle of the list very quickly. When inserting an element in the middle of the list, you have to shift all the elements after the insertion point by one towards the end of the list. This used to take time. But now everything has changed. All the elements of an array uh, are near one another in the same block of memory. So the operation to shift the elements is performed by a very fast low-level command, which is the system array copy. So when to use linked list, there are still some cases that we have some advantage, but most of the case array list is really common. Okay, so I'm gonna show you the difference on the performance between them, how they perform in each situation. But this is the schema, the diagram that I wanted to show you. So this is how a linked list works. So a linked list uses a data structure called doubly linked list. So this is how it works. We have here the first node, okay, which has a reference right here to the next element. So D24 is the reference for this element right here, okay? So it's like column D24, uh, the same approach that we have been using all the time to represent reference to elements as occurs in the computer memory. Okay, so here the first node has a reference to the next one, which it is on the D24. Okay, all right. And the first one right here, we have some color code. So it is previous stores a reference linked to the previous node object. So it is null. All right. And so here we have the node first pointing to this one. So why this guy right here says that the previous element it is null? Because he is the first. It is the first. So there is none before. So the reference to the previous element it is null. So here we are sometimes talking about nodes, sometimes about element, because the element it is not a simple structure. That's why we call nodes, because each element, each node of our linked list, it is composed with three informations. It is the the reference to the previous element, the values itself. So it stores the value of this element of the list and then the link to the next one. So all of these three informations together, they compose the node object. And here, as you can see, if we are talking about objects, yes, we have a class called node, which has all of these informations, all of these uh, features right here as fields or attributes of the class. So we should see a a variable named previous, another for value, and other one for next. Okay, so here, which are the values of our linked list? We have 115, 131, 500, 12, and 13. These are the values of our linked list. All of the other information, they are just reference to the previous or next element. Okay, so here, as we can see, the node first, it is D24, so right here, and then we have the null reference to the previous. If we want to go to the next, if we want to iterate over our linked list, so then we have the D24, it is the first, the next it is F24, so we go forward right here, then we have 131 as value. The next is on the H24. Then we moved here and so on. Okay. And if we want to insert an element to a linked list, we have this structure like this. So we have the structure that we had before. So 115, 131, 500, and so on. They are the same right here on the line 25th. But then we want to add this new guy right here, okay, which has the value 800. So what we need to do, if it was in array list, we should shift all the other elements to the end and then place the new element in the specific position. But using a linked list, what happens is that we need to update this information right here to the next. So it is not anymore H24, but now it is G29, which is right here. And also this other guy right here, which before it was F24, and now it is G29 to point to this new guy right here. As well, we need to set the back reference. So F24 and H24 right here. Okay, and then we still have our linked list. All the nodes are linked. They have references. Okay. All right, so let me show you right here on the IntelliJ. Okay, so first of all, we have the linked list. I'm gonna enter right here on the array, and then, as I mentioned before, we have the node. Okay, so we have the first, last, and if we enter the node, then look at that. We have a private stat class. Do you remember about stat inner classes? We studied about that, and there is no sense. It makes no sense to use the node type outside the context of a linked list. So it is really specific. And here we have the item, the next, so the reference to the next node, and here the previous, so the reference to the previous node. So these are the three informations. We have the item, next, and previous. And they should all be nodes from the same type. Okay. Do you remember about generics? So here we have the class node use the generic, and here it is the letter E for elements. And this is the same of the item. Okay. Yes, so a node is composed of previous, value, and next. Okay, these three informations together, they compose a node. These are the variable fields, okay, the field variables. All right, so right here in our linked list demo, we have a linked list of integer. Integer, it is the wrapper class for the int primitive type. So integer, okay? So back here to our linked list class. So this E guy, it's going to be the integer. So we have a node of integer. So the item will be integer, next should be integer, prev is going to be integer. In every place that we have the letter E. So E, it is a placeholder, as you mentioned it before in our previous lesson. And here it is the placeholder for the type integer. Okay, so integer here, also here, 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 all the other places. Then we have here going to be the integer. All right, so we have a linked list of integers. All right, so what are we going to do with this code right here? Okay, so let me take a look on this. I have to begin immediately. All right, let me comment that and to uncomment right here. Okay, so this command right here, system dot current time millis, is the current time in milliseconds. Okay, so you know minutes, second, milliseconds. Okay, so give us the current time in milliseconds. This is just a way to measure the execution time. So right here we have the beginning time on millis, then we have the current time on millis. So the runtime, so the execution time will be the difference between the current minus the beginning millis. Okay. So here, what are we doing here? We declared an array list of integers, and then we are going to add 100,000. All right. So here we are going to iterate over this loop 100,000 times, and then add on this array list, and then we are going to measure the execution time. Okay. Then we are going to get again the current time in millis. So we can measure the time to perform the same operation using a linked list. So here we are comparing the time to add 100,000 elements to an array list and a linked list. Okay, I'm gonna set the breakpoint right here and then run this code so we can compare both of them. Okay, so let me see right here. There is actually, oops. Okay, so the breakpoint didn't work. Let me set it again. Okay, now the breakpoints work. And we have the execution times right here. So they are really similar. We have 12 milliseconds to add 100,000 elements on the array list inside the array, and 16 milliseconds to add 100,000 elements on the linked list. Okay, we're going to stop. And here, let me comment everything. Okay. I'm gonna run a couple times just to be sure about the execution times. And these times, they vary a little bit when we repeat the execution time. As we can see here, they are inverted now. It was before 12 and 16. Now it is 16 and 11. So I'm gonna run like 10 times just to be sure that they are consistent. So they are alternating a little bit. Maybe you get a little different numbers on your computer in your home than I am getting here. So in our presentation, it said that it was fast and very fast. We are just adding elements in sequence. So as you can see, sometimes one is faster than the other, then other time the situation inverts, but there is no problem with that. Okay, so the results are pretty consistent. We didn't see much difference between all the executions. Okay, so now if I comment all of this and comment the code below, what we have here, oh, I need the variable. Let me add it right here in the same way. Oops, what's that? Okay, and the linked list. All right. Okay, so here what we are doing is defining again an array list and a linked list, and I want to recover. So I want to measure here the time to get an element in any specific position. Okay, so we are going to. Oops, actually, I need to add all the elements. That's why it was not here, because I needed to add the elements and then we are going to just get those elements. Okay. For a release, it is pretty fast, just 24 milliseconds. But to iterate over a linked list with 100,000, it is really slow. So we have like 10 seconds. It is really long. So using the same strategy, we are going to run again a couple times just to be sure about the results. Same way, 22 milliseconds against 8 seconds. There is a lot of difference. Now, 8 milliseconds for array list, and it takes too long, 8 seconds. So it is like 1,000 times of difference between array list to iterate over the collection and to iterate over a linked list. It is a lot of difference, okay? So again, just back to the presentation. So to add an element, it is fast for array list, but it is very fast for linked lists. We saw these times alternating to one or the other. But to get an element, it was very fast for array list and really slow for linked list. The last test you're going to do is to insert an element in a specific position. Let's take a look. So I'm gonna again to comment all of this. And now I'm gonna to sort. Okay. All right. But we are not adding, we are sort. Okay, and here, what I'm gonna do, I'm gonna change to add the element in specific position. So the position is 0, and we are adding the I. So we are always inserting on the beginning. So we need to shift all the other elements using the array list. And in the same way right here on the linked list, we'll be adding on the first position. And the element is the current number right here, okay? So let's take a look on the execution times. Oh, so now we have a different situation. We have the array list being lower than the linked list, which is really fast. So same strategy, let's run a couple times. So although array list is faster now, because of the system.array copy feature, but for linked list, it is really fast, like 100 times faster. Okay, that's it. So the resume of everything is that if you are going to insert an element in specific position, so when you need to shift all the other elements, prefer to use the linked list, okay? If you are going to iterate over a collection, this is the most frequent operation you are going to do, prefer to use a array list. Okay, so this is why array list is so common